All right, so today we're going to be looking at titration of a strong acid with a strong base or vice versa. And then we'll probably do a titration or at least a virtual titration next week. So we've looked at neutralization reactions before. And that's the reaction of an acid with a base to produce water and a salt. And it doesn't have to be sodium chloride. In chemistry, a salt is an ionic compound composed of a cation, a positive ion from the base, and an anion, which is a negative ion from an acid. So if we look at an example of that, we could have potassium hydroxide plus hydrochloric acid. That's a strong acid and a strong base. So my hydroxide and my hydrogen ion are kind of come together to give us water. And then we have the KCl left over, and that would be my salt in that one. We've done those before. It's a special, actually probably a couple of units because our net ionic unit, we did them too. So it's a specialized type of double replacement reaction. All right, we're not going to worry about net ionics because we already did those. So we are going to move on to titrations. It was from this unit? Yes, was it from this unit? Am I confused? I am often confused. Or was that last unit? That was solution. Yeah. No, it won't be. It won't be. Won't be. All righty. Oh, I needed to pick up y'all's web quest. If you didn't turn your web quest in, if you will pass it up. Let's see who I have. Oh, you know what? I think I already did y'all's. I think y'all were the only class that it was in turned in. Did you turn it in? Someone? Okay. I think that's what it is. That's why I can find it. Okay. Only class. I got them all turned in. All right. So for a titration of acid and base, this is not the only kind of titration that there is, probably the most common, but there are other types of titrations. So when you titrate something, you carry out a neutralization reaction of an acid by a base or vice versa. So you would know the concentration and molarity of one of them, whether it was the acid or base, and you were carrying out the titration to figure out the molarity of the other one. The titrant is the solution of known concentration that is in the burette, and the titrant is added to a solution of unknown concentration until the substance that is being analyzed is just consumed and the equivalence point has been met. If you were doing a strong acid, strong base combination, the equivalence point is about when the pH is equal to 7. So that's kind of a true neutralization reactions. If you throw something in that's weak, like a strong base with the weak acid, then the pH when it hits the equivalence point is not going to be right at 7. It's going to be a little higher or a little lower. So what we use to mark the equivalence point is an indicator, and that gives us a color change. So a endpoint is a color change at the endpoint of the titration. And examples are phenolphthalein and methyl orange. Phenolphthalein is very common. I'm just going to put PP for phenolphthalein instead of writing all that out. So it is clear when it's in an acid. But then if I started titrating some base into it, so I started putting some drops of base when I got to about 7, then it would change colors. It would become pink. So most indicators are some type of weak acid. And so when the pH changes, then they go from one color to another. And that marks that the titration is over and that we should have reached the equivalence point. So the equivalence point is the point at which the 2 solutions used in the titration are present at chemically equivalent amounts. So that means my hydrogen ion concentration would be equal to my hydroxide concentration. And once again, for strong, which is what we're doing, that would happen at a pH of about 7. So this is the net ionic, if you remember, that you see for strong acid, strong base reactions. And the pH is easy to calculate when these go to completion. So if we go back to the one that we wrote on the other side, I'm going to write it up here because I'll run out of room down there. Sodium hydroxide, and we said potassium chloride. So when those react, not potassium chloride, how about potassium? I'm getting my AP chemistry and my regular chemistry mixed up. What do I want? No, I don't want that. Sorry, y'all. I want KOH and HCl. All right. So like I said, we're going to have H2O. And then what's left over is going to form my salt, which is KCl. So if you remember, all of these are going to ionize. This is a strong base. This is a strong acid. So it would ionize. And then on my product side, I would have my water, which stays together. But then my KCl would also ionize. So we had a whole lot of spectator ions when we did these reactions. So our net ionic really just ended up being the formation of water. So the formula that we're going to use for this is going to be very similar to one that we've used already. We're just going to add in some information about the acid and the base. So I'm going to have MaVANA is equal to MbVbNb. So M is molarity, which remember is moles per liter. V is going to be our volume. And it can be in any units as long as they're the same for both the acid and the base. So N is what's going to be new here. So N for my acid is going to be the number of acidic hydrogen. So for example, HCl, that N would be equal to 1 because I just have 1. But if I had something like calcium, if I had something like sulfuric acid, like we did today, that N would be equal to 2 because it has 2 acidic hydrogen. And it's just the formula of the acid or just the formula of the base. It's not the coefficients. So in B, it makes sense that we would be looking for the number of hydroxides. So NaOH, I just have 1 hydroxide, so my N is equal to 1. But if I had something like calcium hydroxide, there's 2, so my N would be equal to 2. So pretty easy formula to use. So let's look at a couple of reactions. So on your practice, it's like it usually is. It starts easier and then gets a little bit harder. I will tell you that you're going to have to be able to write formulas on the quiz, and you're going to have to be able to write a neutralization reaction. And that's on the practice too. All right. First of all, let's completely scratch out that because it's not a good reaction. I don't have the same of both things on each side. So let's just HCl plus NaOH gives me my water plus my sodium chloride. That would make more sense. All right, so it says, suppose you know 20 mils of a 0.0050 molar magnesium hydroxide. So all of that information is my base. And if I look at my formula, MgOH2, that means my N for my base is going to be equal to 2 because I have 2 hydroxides. And it's required to reach the equivalence point in the titration of 10 mils of an unknown molarity of HCl. So unknown molarity tells me that my Ma is going to be my unknown. And if I look at my HCl, I only have one H, so I can go ahead and say my Na is going to just be equal to 1. All right, now we can start putting everything in. So I have Ma, which is my unknown, Va, which is, what's my volume for my acid? It says I have 10 mils. And then we said our Na was 1. And then I'm going to set that all equal to my base information, which for my MB 0.0050 molar. My volume was my 20 mils, and that works because both of them are in mils. And then that formula, if y'all like, that is not what I have. So let's use this one. Did you on that? If you look back on that equation that you scratched out, do you see like there's magnesium hydroxide on one side and not on the other? So that doesn't make any sense. So let's use this one. And so then my N would only be equal to, for my base would just be equal to 1. All right, so that's my setup. So now I need to solve for my Ma. So I just divide each side by 10. That cancels out, and that's all what goes in your calculator. And we have 2 sig figs on that one when you get your answer. 0.010 molar. 0.01 would just be 1 sig fig. That leading 0 does not count as a sig fig. So you could write it like that. You could put it in brackets, but you got to do one of those two to show what the units are. All right. Questions on that? Pretty easy. Like I said, it's similar to a formula we've already used one time. All right, let's look at another one, and then y'all can give one a try. All right, so it says in a titration of 27 mils of 0.015 molar barium hydroxide. So once again, that's my base. And I am adding it to a 20 ml sample of hydrochloric acid. So that neutralization is going to give me water plus barium chloride. You have to, when you write that salt, you have to check your charges. Barium's a +2 and chloride is a -1. So that's when they were put together. I had to give it a 2. And then on this one, we'd have to balance a little bit. I would need a 2 here and a 2 here. Then that would be balanced. All right. Once again, we're trying to find our Ma. It said that I had 20 mils of my acid. And hydrochloric acid, I'm just interested in the compound. I'm not interested in the coefficient for this. So it is still 1. And I'm going to set that equal to my MB, which is 0.0154 and 27.4 mils. And for my barium hydroxide, because of my subscript, I have 2 for my N. All right, divide each side by 20. And I think on this one, we're at 3 sig figs if you look up for everything. Point 0.0422 molar. Perfect, would be your answer. All right, why don't y'all give that last one a try? You're gonna have to write a neutralization reaction. Anybody get an answer for this one? 0.0786 molar. That is correct. 3 sig figs. Does anybody need me to go through that, work it out? The only thing that would have messed you up is that you didn't write your sulfuric acid and you had your H as just 1 for your acid instead of 2. All right, so that gives you some time to work on practice. You can either work on this or you can pull out what you're going to have a quiz on tomorrow and work on that one.